In this episode of Cube FM, I got a chance to speak to Stefan Roman about the intricacies of building multi-tenancy in Kubernetes based on his work for a Kubernetes-based learning platform called Labs for Grabs. In this episode, you'll learn how to evaluate the differences between namespace-based and control plane multi-tenancy, the role of tools like vCluster and Capsule, and the trade-offs these options present in terms of isolation, scalability, and operational efficiency. Stefan also shares key insights into how to approach multi-tenant architectures in a way that balances security, performance, and maintainability. If you're looking to sharpen your understanding of multi-tenancy strategies, this conversation packs a serious punch because Stefan is also a boxing fan like myself, which contributed to making this an exceptional conversation. This episode is sponsored by Kusari. Modern software supply chains are full of vulnerabilities. With limited visibility, no one sees the full picture. Incidents are inevitable. Panic is optional. With Kusari, you'll know exactly what's in your infrastructure. Introducing the Kusari platform that stores, tracks, and analyzes SBOMs and delivers insights. Securing your software chain starts with transparency, and transparency starts with Kusari. Now, let's check out the episode with Stefan. Stefan, can you tell me what are 3 emerging Kubernetes tools that you're keeping an eye on?
So I'm not really sort of paying attention to emerging technologies, but in general, I'm paying attention to Kubernetes itself because it's the most important thing in Kubernetes world. It's Kubernetes itself. There's been some great development recently, particularly with I think Kubernetes 130. I think is it correct? I'm not actually sure, but there is some features with the PVCs that I would like to use for Labs for Grabs, for example. So this is I'm just searching GitHub and release notes and stuff like that, and whatever people say, whatever my colleagues say, and some blogs and things like that. So also I'm keeping an eye out on KubeVirt. Of course, it's a big part of Labs for Grabs. So definitely on GitHub there is some great release notes. There is a lot of people contributing to that project, so that's great. And then something, it's not definitely not emerging, but observability stack. So like Grafana, Prometheus, and Loki, Tempo, and things like that. That's because at my job there has been few times when like a mishap in configuration caused huge costs to spike. So wild API calls to S3 buckets and things like that with Loki. So that's kind of like spiked the costs up. So this is definitely worth to keep an eye on to avoid mishaps like this.
Very good. Now, tell me more. What do you do? Where do you work?
I worked at a company called Labyrinth Labs as a DevOps engineer, and we specialize in designing and building cloud-native infrastructures, mainly in AWS. We have some Google Cloud customers, but this is 99.9% AWS, and we heavily focus on Kubernetes and serverless technologies.
What did you do before cloud native?
Oh, wow. So a lot of things. I was never like an IT guy. I mean, people thought I'm an IT guy because I knew where, I don't know what on Windows control panel was, and that was like the mind-blowing thing for them. So I never was really an IT guy. I used to play a lot of games. So some like my first job was in a data center. I was an apprentice in a data center. So that was definitely not cloud native, playing around with physical Cisco devices and then configuring them. Working in the data center, lifting manual labor, an actual manual labor in an IT job is very rare. So that was definitely a part of it. And one interesting thing which I can mention about data centers is that you have cold and hot aisles in the data center. So the hot aisles are where all the servers and networking devices output their heat, and then cold aisles is where they suck in the cold air, and that's where the aircon or air conditioning is functioning. So, if you have a lot of cable management at the back of the data center, at the back of the hot aisle, you get all sweaty, and then you have to connect something at the front of the aisle, and you get a cold. So cold was quite frequent in a data center for sure. At least the one I worked at.
Okay. All right. So when you weren't getting, hot and cold, you did eventually get into cloud native technologies. What was that process like?
I never actually thought about getting into cloud native. I didn't actually know what it meant. Cloud native is such a large scope of things and sort of technologies and principles and God knows what. But I started working. I always wanted to work with AWS Cloud. That was my main focus. I did some certifications and the associates AWS certifications, and I really wanted to work on AWS Cloud, whatever it was. Auto scaling, load balancers, S3. That all seemed like the best thing in the world for me at the time. So I always wanted to work in that, and I always tried to find employers which had this stack. And fortunately for me was that I found employers which dabbled into containers, Kubernetes, big auto-scaled environments. So it kind of just happened for me. I never actually wanted to go into cloud native, although it's great. So after a couple of employments, I started to dabble into Kubernetes because one of the employers was based in Slovakia, also Piano. They had this a paywall for newspapers, for online newspapers. So every time a huge event popped up, the auto-scaled environment just like spiraled out of control. All of a sudden, there was like 200 servers. And when nothing happened, then you had like 2 or 3. So it was like a huge dynamic environment. And they wanted to dabble into Kubernetes and auto-scale applications that way because they thought it's going to cut them some costs. So that's when I actually, noticed Kubernetes as a thing. It was quite new at the time. I'm not sure what version that was, but yeah, that was one of the main cloud native technology was Kubernetes. That's when I got to know that. And I guess since then I am a cloud native engineer.
Certainly. Yep. And you mentioned previously about, blogs and, different resources to stay on track. The Kubernetes cloud native ecosystem moves very, very quickly. What resources are your go-to places, to learn or to level up?
Definitely Reddit. r/Kubernetes is great. r/DevOps is great. People post all sorts of problems. Some easily solvable, some not as easily solvable. But it's a great place to learn, and there's a lot of marketing happening in those subreddits, so you can definitely keep an eye on emerging technologies. Also, there's plenty of new technologies advertised in those subreddits. So, and also Medium, it's also a great platform of new technologies and all sorts of problems that people have in the infrastructure. So.
If you could go back and give one career tip to your younger self, what would it be?
Well, I thought about this, and just slow down. IT is a complex field with all sorts of machinery, all sorts of moving parts, and I would just like to kind of slow down and understand why things are failing. So that's definitely an advice. And for actually people who are starting, just understand why things are failing and not just, okay, so this is failing, push it aside, let's just try something else, because that's how I was.
As part of our monthly content discovery, we found an article that you wrote titled Exploring Multi-Tenancy Solutions for My Kubernetes Learning Platform. Let's take a look at this more in detail. Let's start with an overview of labsforgrabs.io. Can you explain the platform and the problem it's trying to solve?
So yes, I can. And when I did my certifications for CKA and CKAD, I never did CKS. It's something I want to do, but when I did those two and I looked at the resources available online, and mind there is great resources for learning. One being a Code Cloud, some Udemy courses, and there's plenty of clever people that can pace the content in a way that is digestible, so you learn as quickly as possible. But I thought that it's not really real, like create a namespace or create a pod, create a deployment. It's not really that something that happens in the real world. You have Helm charts, it will do all this heavy lifting for you. You have problems with Helm charts, you have problems with templating, you have problems with Kubernetes, kubelets, resources, hardware, things like that. So I always sort of fantasized about, a platform that can teach people those kind of real skills. And Labs for Grabs is kind of that fantasy. It's a Kubernetes learning platform that will give you root access to the environment. So there is a Linux environment. It's a Kubernetes cluster. Usually it's up and running. Sometimes it's broken and you have to fix it. It definitely focuses on real world problems. It's some of the problems which I experienced in my career. And it's for free. So
It's also nice that it helps when things are for free.
yes, definitely.
I imagine that there are some significant technical hurdles when designing a platform like this. What were the main challenges that you encountered during the development process?
So definitely it was security. Well, because my fantasy was to provide root access to the users and full access to the Kubernetes cluster, so they can run privileged workloads and things like that. So security was definitely a main focus of that. And for instance, at the start of the multi-tenancy as a whole was a security hurdle in itself, because there is multiple multi-tenancy solutions. There is a huge, whether is the actual concept, whether it's the actual technology, and how the technology approaches this concept is all varied. And I actually needed the maximum type of isolation, and there are a couple of technologies that go around, solving that problem. And the one of the biggest challenge was actually learning those technologies, how they operate, whether I can misconfigure something and then there's going to be a security incident, somebody's going to log into my root cluster and break things or read something which they shouldn't have, or secrets, things like that. So security was definitely a main part of the problem, and also the main problem was me, who was not really experienced in those kind of technologies. So I didn't actually trust myself because I never knew those technologies. So that was definitely the main issue. And another main issue was the resources, and we'll probably gonna talk more about that. But the resource allocation, of course, I cannot allow students to have 256 gigabytes of memory per lab. That's not really feasible. So I really had to limit the amount of resources to a point it would be feasible for me to run, and for the actual student to have the best type of experience, things not crashing, or people pods being scheduled properly, or the workloads that are part of the curriculum or the lab are not falling over. So that was definitely challenging to give that sweet spot.
Now, many developers might assume that Kubernetes namespaces provide sufficient isolation. Why didn't namespaces meet your requirements for this learning platform?
So of course developers might assume, So the problem with the namespace isolation is that you usually do this isolation when um, you provide the resources to people who you trust. I cannot trust the public. So the namespaces work actually, great. There's great technologies. I think I researched a technology called Capsule. I'm not sure who that technology is from, but yeah, I think it was called Capsule. And the main issue with namespaces was that um, there's quite a lot of configuration around namespace multi-tenancy. So there is a role-based access control. You have to generate a kube config. You have to create a user. The role-based access control needs to be defined per lab. So you can't run privileged workloads. So because of course you run a privileged image, and people can just log into your root cluster and read the file system or read other pods and things like that. So it's complicated, and it's not as secure as one would think. For people who you trust, of course, you have a development cluster and you assign this namespace to a developer, and they can develop stuff, and then they can destroy it and build it back up. But for public use, it's definitely dangerous.
Given the limitations of namespaces, you must have explored other options. What technologies did you initially consider for addressing these multi-tenancy challenges?
Initially, I actually found vCluster and tried to wrap my idea of the lab and the content that I want to do around vCluster, which was vCluster is self-healing. So if you break Kubernetes API, the whole vCluster falls over and rebuilds itself back up. So the content that I really wanted to do, like break API server, break scheduler, break kubelet, break all sorts of different components of Kubernetes, that was not feasible anymore, because you really need SSH access. And vCluster is just a container that you log into via a kubeconfig. So of course, a lot of content that way kind of falls apart, and I could not do a lot of it. So, but I still try to use vCluster and do um, and wrap all my ideas around concept of vCluster. But it really fell apart when I realized that vCluster runs a container, and if I really want to sort of teach students how to run privileged workloads, then I cannot do that, because the way vCluster works is that it's just like a fake kube API server, and the fake kube API server is scheduling every single thing that the student might want onto the host cluster. So if they schedule a privileged pod, then they can exec into that pod and get access to my cluster, which is, again, with all things said, I cannot allow that. So of course you can prevent that with the vCluster. There's flags for that, but I really wanted to provide privileged content also. So that thing kind of fell apart on that. And of course, there was Kata containers, there was Firecracker. Unfortunately, at the time, Firecracker is great, by the way, because it's extremely fast. It boots up extremely fast. It's just a container. There is no kind of really heavy lifting behind that. So I really wanted to explore that, but at the time, Firecracker needed additional configuration for it to be run in Kubernetes environment, and that was kind of really low-level stuff like VDEV, and I found like a guy who created a bash script to get around the problem, and I didn't really feel like the technology would be suitable for like public use. So of course, AWS Lambdas run on Firecracker, I believe. So that's definitely public use. But for me, on Kubernetes itself, it was kind of sketchy. it might have improved. I mean, I definitely would like to re-explore that. That would be nice.
Now, I know you mentioned vCluster. Can you elaborate a little bit more on why it seemed promising initially and what your experience was like in terms of implementation, specifically on the Syncer feature?
Mhm. Yeah, sure. So, I mean, vCluster is great. It's great technology. Like I said, it's just a fake Kube API server. You just deploy a Helm chart. It will create a pod on in your system in your namespace which you define, and that pod acts as a fake Kube API server. Uh, and from then you receive a kubeconfig, which is a public kubeconfig file, and you can log into your kind of a new Kubernetes cluster. However, um, the vCluster doesn't really have components such as scheduler and things like that. It uses the scheduler on your host Kubernetes cluster. So it's really kind of dumbed down version of like I said, full blown Kubernetes cluster, because it uses quite a lot of components from your base cluster. When it comes to the Syncer feature, it's been absolutely great, because some of the content which I really wanted to do was networking. So it's when we talk about the real world applications, quite a lot of applications there. They are communicating to the outside. They are accessed from the outside, like I don't know, websites, different kind of API servers, things like that. So what the Syncer feature did was, if you receive this kube config, you schedule your own pod, or that gets scheduled on the host operating system, but it's inaccessible yet. You deploy a node port service, and that node port service will get replicated onto your host cluster, and therefore you can expose the service that you scheduled on the vCluster from the outside. So you can deploy a website, and if you have the public IP address, you can just access it from the outside via node port, or you can deploy an ingress object. And then, of course, if you deploy an ingress object, you have to do some kind of etc host magic to be able to access that, but you still can do that. So the Syncer feature for networking content was absolutely the best thing ever. And I felt actually really sad to move away from vCluster because of all the disadvantages that it provided, because of that Syncer feature. And in a blog, I believe I said that I will try to program the Syncer feature back in. It's kind of fell apart recently, because I realized that it would provide students with ability to host nasty stuff on my infrastructure. So I kind of prevented that. It's still in the works. I still have the code up and running, but it's not available because of the security concerns. I don't want to get banned, on my cloud provider because of some stuff that somebody is hosting.
You don't want your students hosting, dark web and doing crypto mining.
Yeah, exactly. And that's what initially I actually had labs for grabs, and every single lab having outbound access, so outbound access to the internet. And that was because I wanted students to, I don't know, upgrade Kubernetes cluster, and you really needed to have access to the apt repositories, or like Yum repositories or whatever. But I actually had a lab on upgrading Kubernetes cluster from, I think, 1.5 to 1.6 or something like that. But I cut off the public access, egress public access, because of, of course, security concerns, because you can actually host a miner on it for like an hour and, mine some stuff, and then, repeat the lab, install the miner again and again and again. So it's definitely a security concern.
Very good. Now, I imagine as well on that topic, providing full Kubernetes clusters to students is, it's no small feat. What other approaches did you consider before settling on your final solution?
So I mean, definitely the vCluster was a strong one. Definitely Firecracker was a thing. But ultimately, um, the full blown virtualization one, and that was the libvirt KVM virtualization, which was provided by KubeVirt. So we can talk about KubeVirt for forever, but that technology ultimately won the fight.
Now, KubeVirt isn't a technology that all of our listeners might be familiar with. Could you explain how it works in the context of your platform?
Okay, so KubeVirt is just another controller in your Kubernetes cluster. You install it, and what it provides is that it provides a connection between a Kubernetes pod and a full-blown virtual machine that is hosted on your hardware. So what it essentially means that you can deploy a custom resource object, which is, I don't know, let's just say a virtual machine, and that custom resource object deploys a Kubernetes pod, which is directly coupled with a virtual machine on your host system. And that really means that you can use networking policies, expose services via service objects, node ports, things like that, and use all the Kubernetes objects around your virtual machine. So in the context of Labs for Grabs, what it means is that it provides a really isolated environments while still having benefits of a Kubernetes cluster. So I can use networking policies to separate. So if a person connects to a lab environment via root, they can definitely ping all other IP addresses on the cluster. Well, I can use networking policies to prevent that completely. So that virtual machine is completely isolated on my Kubernetes, or well, the root system, but it's the front end of that is the Kubernetes pod.
Implementing any technology at scale often comes with its own set of challenges. What were some of the key technical decisions you had to make when implementing Cooper?
So definitely, it's a challenging technology because it's complicated. KubeVirt is a virtualization, and virtualization it's an animal of its own. It's really complicated technology. Coupled with Kubernetes, is that much more complex. So yeah, that was the main challenge.
Okay, fair enough. Anything that you might want to speak about more specifically about containerdist and implementing a cache?
The main issue with the KubeVirt, or the main kind of decision with KubeVirt, was to there is a technology or mechanism to use persistent volume claims or container disk images. And the way it works is that you create yourself an image with the operating system with all the packages installed as a persistent volume claim. And then if you want to use the same image, you have to clone this persistent volume claim somewhere else. I mean, to a different namespace or somewhere else where the student might want to spin up another lab. But that took about maybe sort of close to 10 minutes to migrate a single persistent volume claim. So definitely that's not really feasible. So I tried to implement a cache of labs initially, and the problem with that was that the cloning sometimes failed, and I really had to create a mechanism to remove the persistent volume claim and start over the cloning process. And it was really it felt like really heavy lifting of really heavy way of doing things on Kubernetes. So that's when I noticed that KubeVirt provides container disk images, and the way this works is that it's a same kind of image, but it's a virtual machine that is exported in a raw file, and then it's mounted in Docker container under a specific path, and then the Docker container is built. And that way you can just push this container into Docker Hub. I mean, it's large, it's like 8 or 9 to 10 gigabytes big, but you can push it into the Docker Hub, and every time you require this Docker image, then you can just pull it from the registry, or if it's cached in Kubernetes, you can just use it, and it's up and running in seconds.
Running full virtual machines for each student environment seems somewhat resource intensive. How do you manage the performance and cost implications of this approach?
Well, I kind of dabbled into it in the beginning, but the initial I'll tell you how it worked before, and it worked before by giving you 3 virtual machines with every single lab environment. So I decided to allocate 1.5 gigabytes of memory to the control plane node, which is its own virtual machine. That seemed to be enough to run all the sort of control plane components. And then 1.1 gigabyte for a normal kind of worker node that might come with a lab. And every single lab had 3 nodes every single time because they were in the same namespace, and it came as some sort of a package. So every single time a student clicked claim lab or start lab, then they would receive 3 nodes, which is close to 5 gigabytes of memory and about 3 vCPUs. So it's a lot of resources. But then I created a mechanism to limit that, and the way it's limited now is that the labs which require 3 nodes still have 3 nodes, but the labs which just require, I don't know, a control plane, they just get a control plane node. Or labs which require a control plane and 1 worker, they get that. There might be labs which require a single control plane node and then 5 worker nodes. I mean, I can't imagine a lab like that, but in the future, it's possible. So that system is really kind of dynamic right now.
Resource management in a learning platform can be tricky, especially when students might abandon exercises. How do you handle scenarios where students start multiple exercises and then stop using them when they're not crypto mining, of course?
Yeah, okay. There's definitely something of that nature going on, but the way I manage this is that a student can only start 1 lab, and if they don't end it, or if the lab does not time out, they cannot start another lab. So there is a mechanism that always checks whether if a student is actively working in a lab or they received credentials, and then doesn't let them spin up another one. So that's the mechanism to prevent students starting multiple labs, and then each lab has a time limit. So currently all labs have 1 hour, and sandboxes, I believe they have 2 hours time. I'm not sure now about sandboxes, but they might have 2 hours. So if the 1 or 2 hours is up, then there is a service that kills the lab and tells goodbye to the student. So that's how it's handled.
Okay, good. Now, we've talked about security more than once in this conversation, and for very good reasons. When it being such a critical concern in multi-tenant environments, how do you address networking security in your Kubernetes setup? I know we talked about network policies. Could you talk about that? But is there anything else that would be beneficial to know in terms of the setup that goes into this?
Yeah, so like I said, the initial idea was that the Kubernetes lab was consisting of 3 nodes in the same namespace, and it's really easy to set up a network policy to cut off a single namespace from the rest of the system. I mean, it's very simple. You just mentioned that you just create a network policy, and then have all inbound and all outbound access to the internet allowed, and all the rest is pretty much prevented, apart from DNS, because you gotta communicate with the Kubernetes DNS, otherwise things break. But in the new system, I have 2 namespaces. So I have a namespace per control plane, and then I have a namespace full of worker nodes. And when a student initiates the lab, then the system will connect to claim the nodes first, depending on how many are needed, and then make necessary connections between the namespaces and the labels that that are required for the control plane to communicate with the workers, and for workers to communicate with the control plane from other namespaces. Plus, of course, the kube DNS, that's definitely required for all the components to access. And the way it works publicly facing, only control plane node is exposed to the public. Also, the labs are all cached. Okay, so they're all waiting for the students to claim them or to start labs. And if a student starts a lab, then a node port service is created to allow them access to the system by SSH. So I don't pre-create anything. So if you scan the host, then only one port is open, and that's the API server. So everything else is prevented and secured until the student, of course, starts a lab, in which case the node port is opened, and then student can have access to the control plane node. And from the control plane node, they can have access then to the worker nodes.
Now, looking forward, towards the future, what developments or improvements are you planning for lab4grabs.io?
Wow, a lot. Particularly regarding content. I really want to create some content for the CKA and CKD exams, CKS also, but just more content. I had an idea of providing a repository for the community to create their own labs, because I have a system. I have like a YAML file that defines all the checks, all the node labels, taints, and things like that, which you might need for your lab. I have a script that installs stuff before. I have a script that installs stuff after, and I think it will be really interesting to see what people will come up with. So that would be nice. Also, one thing that would be nice is to provide this technology to companies which want to test their potential candidates. So something like that is definitely something that I thought about, and I think this public repository will make this happen for sure.
Interesting. Just to take that a little bit further, because you mentioned, the process of certifications. There's a somewhat of a debate around this. Like, is a certification a good way for a company to know if someone will, do a good job? But you're proposing that, that there could be other ways to do that. What are your thoughts on certifications as a way of validating someone's ability to be, a solid engineer when it comes to Kubernetes?
So of course, a certification is just a piece of paper. It just says that you did this thing. You created some deployments. You created the stateful set. You repaired kubelet. You have a basic understanding of how Kubernetes works. But when it comes to real world problems, I think that's kind of lacking. But I mean, it's fine, because if a company feels comfortable with hiring you based on their certification, you will get some knowledge, real world knowledge on the job. You have plenty of resources online when you start. So
And reflecting on your journey developing labs4grabs.io, if you could go back and start over now, what would you do differently?
just probably use Kubernetes a lot more, because the way it worked before, it was by GitHub pipelines. So GitHub, or GitHub Actions, that's what it's called. And when a student did some action, claim a lab, or the labs were created, cached, or whatever, it was all done via GitHub Actions. And I would definitely invest more time into creating a Kubernetes service that creates the labs, caches labs, and has access already to this Kubernetes environments. rather than GitHub Actions. So Labs for Grabs doesn't use GitHub Actions anymore. It's purely on Kubernetes. There is I think almost 10 services that take care of different aspects of Labs. But definitely I would start with Kubernetes in mind first, and then I think it will be easier.
All right. Now, getting towards the end, we found out that you're into mountaineering and boxing. I don't have climbing gear, but I do have my boxing gloves nearby because I also do love boxing. So tell me about
Awesome.
your hobbies. Tell me about mountaineering first, and then we can start an entirely new podcast episode about boxing. But tell me first about mountaineering.
So mountaineering in Slovakia, we have a nice mountain range called Tatras, high and low Tatras, but the high Tatras are where the magic happens. So I mean, I really like nature. I was
Yeah.
always a freak when it comes to nature. So unfortunately, I don't have a lot of time right now because of all personal
Everything that you
problems
just
and things like that.
explained. Yeah.
Exactly. Yeah. So
Yeah.
so it's a little bit difficult to find time because you have to travel somewhere. You have to usually stay overnight because you have to get up early in the morning and do the mountaineering stuff. So I don't have a lot of time, but hopefully in the future I can get back to it.
Okay, great. If you're ever in the north of Spain, in the Basque Country where I live, we have lots of great places for mountaineering,
Sure.
for
Yeah.
everyone that loves nature. But I would love to travel to Slovakia to see what you're describing there. And now tell me about boxing.
Yeah. So I used to live in Britain, and I got into boxing then. It was just something for me to do, and I was never a fighter guy. I was getting into boxing not to fight, but only to do the bags and just to get some cardio in, and it was just something to do. Then I got into sparring and got my face pretty beat up by one guy, so I kind of left boxing for a while. But then I moved to Slovakia and started to actually fight, not matches, but sparrings and stuff like that. It's kind of a big part of my life right now.
Good for you. That's fantastic. Yeah, I've been involved in martial arts for quite some time, but now I've been for the last few years I've been focusing on boxing, primarily for what you said of the fact that the workout's really good. The element around sparring, it can be very violent. It doesn't have to be. It can actually be something that's really controlled. And for me, it's beneficial not just for cardio reasons because you exercise. It's very heavy duty exercise, but a lot of it's about emotional control and sort of slowing down your reactions. And I find that
Absolutely.
part to be really helpful for lots of different things because in terms of concentration, in terms of focus, in terms of reading a situation, and in a moment where your body's in extreme tension to trying to be applying as much calm as you can, I find to be a very interesting exercise.
Yeah,
So
and the
yeah,
calmer you
we
are,
could.
the more you can handle, right? I mean, if you take hits when you're calm, then you're already halfway won.
It's absolutely true. And I think that sometimes it's a metaphor for a lot of other things in life where, like, in the business world, in the work world, you're going to get hit. There are going to be problems. How you react to it or how you're prepared for them, when they do arrive, I think that's where the difference is. So, yeah, we will talk a lot more about boxing when the recording finishes.
Yeah, awesome, sure.
But that's great. It's great. But I think it's really nice too because talking to you because people have a certain image of what they imagine combat sports might be like, and the reality is very, very different from that.
Yeah, very
For
different.
me, when it's done well, there's an immense amount of respect and trust and care and support for everyone who's doing it, and it's not about trying to break somebody's face and make sure that they have a bad
Yeah.
day. It's not about that at all. So that's
Yeah,
good.
there is some of that. I mean, people come from different backgrounds. They have different kind of personal issues and things like that. And some people tend to take it up a notch. And I mean, before when I was starting, I was kind of scared of those people, and now I'm like, okay, let's bring it on.
Just another part of the experience. I do think that the gyms can influence, the way in which it's approached and the way in which it's understood. But like you said, sometimes there are people that are very much on a mission and you have to
Yeah, exactly.
keep that in mind
That's a
before
good
you
way of
step in
put
the
it.
ring. Yeah.
Yeah, good way of put it.
All right. So you're quite busy with a lot of different things, but what's next for you?
Well, actually, I just want to keep doing what I'm doing. I'm really happy where I'm currently at. I mean, I have this side project, Labs for Grabs. It gives me quite a lot of skills. I have a great job full of people with much more experience than what I can dream of. So it's a great place to be. Interesting problems to solve. So I just would like to keep doing what I'm doing at the moment.
And what's the best way for people to get in touch with you?
Definitely LinkedIn, although I'm not. I need to install the app now on my phone so I can get the notifications on my phone. So definitely LinkedIn. You can just email me, and I'll definitely respond. Or I mean, a great way to connect with me is via Slack. Just connect to Labs for Grabs Slack, and I'm pretty much there 24/7.
Great. Well, that being said, very nice having you on our podcast today, hearing about your experience. Keep up
Thanks
the
for having
amazing
me.
work. Yeah, and we'll be looking forward to seeing your next steps.
Thank you very much. Thanks for having
Cheers. Take care. Bye bye.
me. Bye bye.